Hello students. So in this video we'll finish up the last two properties of indifference curves. So property number 6 is that utility doesn't change on an indifference curve. So remember, utility is how much happiness you get from consuming these goods. An indifference curve connects all the combinations that are equally good. So this over here is just as good as this one down here. So they're both equally desirable, and utility is how much happiness you're getting from them. Then they're both giving you the same amount of utility. So maybe all the combinations on this curve here give you a utility of, let's say, 8, just to pick a number. We can start combining things with stuff we learned earlier. And we said that the consumer wants to be as far out as possible in this direction. We're going to be going out here. So we have some other curve over here, then stuff on that curve is more desirable than stuff back here. So the utility you get from things over here has to be bigger than that utility. For instance, you have goods like this one out here, which give you both more x and more y than that one does. So that one's 8. Stuff over here might be, maybe that's a 10. And maybe there's some even higher difference curve out here where things are even better. So utility for this one has to be greater than 10. Maybe it's 11. So what we're saying is that all the points on this curve, all they give you is 11 utility. And everything over here gives you 10. So this one gives you 10. Same down here, it also gives you 10. Everything back here is an 8. Again, that's because indifference curves connect bundles that are equally good. So if they're equally good, they have to give you equal utility. So utility does not change along an indifference curve. One more property. So our last property is that indifference curves cannot be thick. So we'll approach this one in the same way we treated a couple of earlier properties. We'll say, well, what if indifference curves could be thick? What would that lead us to? If that leads us someplace that's impossible, then we deduce, oh, so they can't be thick. So this would look something like a graph like this. So a thick indifference curve might look like this one over here, where all the points in this band are equally good. So here's why this is not possible. So that indifference curve includes a point out here, but also includes a point back here. So let's call this one here, we'll call this one, let's call this one H. And this one is J. So H and J are on the same thick indifference curve. So indifference curves connect all bundles that are equally good. So the same indifference curve, then H and J are equally good. So you'd write this. Indifferent between H and J. However, one of our assumptions would make a different claim about H and J. So more is better would say that J is preferred to H. That's because J has more of X, and also J has more of Y. So a contradiction where H and J are equally good and J is better. The assumption we're actually violating here is completeness. Our completeness says either one's better or they're equally good. You can't have one better and equally good. It's either one better or equally good. So this is how we prove our point here. If indifference curves could be thick, the impossible happens. The impossible can't happen. That's how I know indifference curves cannot be thick. So that wraps up our properties of indifference curves. In our next video, we'll talk about budgets.